mechanism where oxidation of NADH is coupled with synthesis of ADP. So where is it happening? So it is coupled with NADH, oxidation of NADH, and synthesis of ATP. So at the electron transport chain, we know all the reduced coenzyme that NADH. This goes there as the reduced coenzyme, and they release their electron, right? So that is the oxidation of that, because they are releasing their electron, and that electron goes to the electron transport chain and move from one complex to another complex. Eventually, what we get at the end? Production of ATP. Right? So that would be the electron transport chain. The next one, number 6. Consider the following two reactions. So there are two reactions given, 1 and 2, and we can see that their energy changed. Free energy changed also given by the equation. And you are asked that using the above two reactions, determine this is true about the following reaction. So now we need to find first, because we can see that the answers are asking for the exergonic or the spontaneous. That we can only know if we can calculate what is the delta Z value for this reaction, if we can calculate that, or if we can find out that. And that is possible by using these two equations. So we can see that the fructose 6-phosphate is a reactant here, and it is a reactant in my targeted reaction. And the fructose is the product, so fructose is the product. So it's telling me that this reaction I should use as it is, because I am getting the reactant and product as it is. For the second reaction, I can see that here my reactant is ADP, but for this second reaction here, my reactant is the ADP is the product instead of the reactant. So that means this reaction I cannot use as it is. I need to modify to make the ADP as the reactant. So the equation, so that will be ADP for that one. If we reverse the reaction, the sign of the delta Z value would change to positive, because that was negative. Now it is going to be to see if the given reaction is matching with that. So now if I add these two equations, and I know that the identical quantity from the left hand side and right hand side you can cancel. So, like for example, what can be cancelled? This one and this one can be cancelled. I have fructose, I have ATP, and that's all. And what will be the delta Z? Now, by adding these two. So that will be minus 3.3 plus 7.3. So that positive sign is bigger, so it would be, the result is going to be plus 4.0. That would be the delta Z value for this reaction. The reaction is endergonic, and if it is endergonic, it is a non-spontaneous reaction, because only exergonic reactions are spontaneous. So positive sign is telling us everything. So that means we can forget these two. So endergonic cannot be spontaneous, never ever. Endergonic always non-spontaneous. Make sense? So you need to look at that what reaction, what is your product and what is your reactant. And based on that, you need to do your calculation. Of the following reaction. So what is going to be the product of this reaction? So we need to look at that. What are the reactants? Reactant, we can see this is one of the reactants, and these are the coenzymes given, and we can see that clearly that NADH is becoming NAD+. So what is happening? oxidation or reduction? So, if the reaction is going to be oxidation reaction or the reduction reaction? Because this is our substrate, this is the coenzyme. We don't concentrate on the coenzyme. Coenzyme, we know that if one is oxidizing, another one will be reducing. But our focus point is what is going to happen to this one if this one is changing to that one. So that must be reduced because it is being oxidized. So the hydrogen would be transferred to that one because look at that, it loses the hydrogen here. So somebody has to take that hydrogen, and we know that the addition of hydrogen is the reduction. So we must have the reduction product. So now where we can add the hydrogen? So reduction of the carbonyl group, we know before we learned that if we have the carbonyl group, like for example, if we add hydrogen, what's going to happen? We add a hydrogen here, another hydrogen here. That will give us alcohol functional. Reduction of the carbonyl group is the alcohol. So that is telling us we must have the reduction. So we should add hydrogen. One hydrogen should go here, another hydrogen should go here. So that would give us that would be the product. So which one is that? Look like this one. Make sense now? Any more questions?